Okay, number 1.
Now you're going to use the chain rule.
It says, find dy over dx, y equals sine times x cubed minus 5x plus 9. Okay, so basically, what we do is we find the derivative of sine, which is cosine. Then you chain rule it, so leave the inside the same. Then multiply it by the derivative of the inside, which is 3x squared minus 5. So you can move the 3x squared minus 5 in front. I know. Cosine x cubed minus 5x plus 1. This is your answer. Also D.
Any questions about that one?
Thank
I
you.
think that was probably the easiest question ever.
Alright. So,
Number 2.
wait, does it go like off my cut? Do what now?
You don't have to keep your hand off the board because it's that.
Oh, that's what I see. That's why it always moves. Okay. All right. Here we go. So we got y equals and 3x, and
always look jumpy like that.
we want to find the second derivative. So for the first derivative, shut your mouth. All right, so we don't have to do power rule, so we do the trig. So we get secant squared 3x because that is the derivative of tangent. What are you laughing at? Yeah. And then you do let's just leave me alone. Then you do the inside, and this equals 3 secant 3x, and that's your first derivative. Oh, sorry. Then you got to do the second derivative, and it would be so first you do power rule, so it'd be 6 secant y. What's wrong? What? Well, I'm trying to. Then you do the trig, and the derivative of it is secant x tan x. It's not a bug, it's just right. What do I do wrong?
Explain it to them, they don't understand.
First you do power.
Power?
You do power rule. So the 3 times 2. I know 3 times 2 is right. It's 6. So it goes in front of the secant, and then after you do the power rule, you do the trig because that's the second step. And the derivative of secant is secant x tan x, and then you do the inside, which is 3. And then it all just the 3 goes with the 6, and it goes to 18 secant squared because the secants multiply. Y'all are like so trying to bug. Like it looks fine. Like y'all can read it, right? I mean, on what?
You don't know why that middle chunk is in there? Because you have to also do the derivative of the actual trig function. The derivative of secant. That is.
Like look on the.
I don't remember.
Look on the.
Like the derivative of sine is cosine.
Like on this one, you didn't have to do power rule because I mean there's. So you just got the derivative of tangent. I mean, you're doing the same thing here, except you got to do power rule first, then you do the derivative. Then you do the inside.
If you look on your derivative sheet, the derivative of secant x is secant tangent. Yeah, I'll just explain it. It's just 3. I worked 3 2 different ways to make sure.
The answer is E. 243. Oh.
Oh, well, number 2 or number 3?
You didn't wait. We had 3.
Oh, 3 was E.
Are you serious? You know, if you would wouldn't have changed the answers on there, I would have gotten that right. Because my answer I got was 243. And I was like, how'd they get it over 302? So I just picked, I was like,
Then it would have been right if it's
yeah, but if I would have picked E, it would have been right. Because that's what you said.
he wasn't quite right. Okay.
Okay.
Thank you, Dylan. You did a wonderful
Good.
job.
I can put my hand on it, right? Okay. So f of u equals u cubed plus 1. And u equals g of x, which equals, I don't
I don't know
know.
how
Oh, wait.
Lizzie's gonna do this, but remember.
I can't
you can do
erase?
this by plugging in, or.
I think that's what I
you can do
did.
this by use substitution first.
Okay. So then I made this equal, so f of u equals, and I did the power rule and did 3u squared times du dx, right? Or would be du. Okay.
But you have to do the DU, remember. That's what, y'all kept coming up and I kept going, you're missing something.
So
You're
what's-
missing something. You're missing something.
I thought you had.
And that's it.
Wait, why'd you have to do times du?
Because you have
Because
to.
U is a whole function. Remember, when you.
It's like
take
a
the
Y.
derivative, you still do dx. Like if I do 5x. it's
I
just
knew I
that
had
the
a
dx
chain
is
rule,
one,
I just
so
didn't
it's
know how.
just one. But here, because U is an entire function, I have to do the derivative.
So then I found
Oh, well, then I know
that
I-
u equals 3 root x. Oh wait. How do I undo?
Why'd you do that?
3x, and then u equals 2.
She's taking the derivative, because look
I
at
took
her,
the derivative
prime
of that.
U, she's got DU. If you ever do a D substitution, you have to, when you take the derivative, you have to follow it.
No, I stuck.
Did you do 3 root x? You could have, that's another way.
Alright, so I got
But
that.
it didn't work.
I got that for the derivative.
Okay. So then I just plugged everything in. I made it 3 times 3 root x squared times 3 over 2. And I just put the x in the bottom. Or the root x in the bottom to make it easier. And then I plugged in 3 for everything.
Why'd you plug in
I
three?
just substituted because I didn't plug in 3.
She didn't plug in 3, she plugged in, so look, point to your F prime of U.
I need a pointer. How do I point? Oh, there it is.
So,
Over here.
she took the U from the right side.
Can y'all see what I'm
And
pointing
plugged
at?
in for that U. So, she replaced that U with 3 root x.
They're putting arrows.
Yeah. You're
And then
saying
she
I'm not done though.
she replaced this U with that, and then she would replace this with this.
I just substituted everything.
I would have gotten it right. I just didn't do the U.
I substituted.
plugged in first.
You gotta do the derivative first.
Yeah, you can plug in.
Can we do the other way?
Yes, but listen, the reason that I've exposed y'all to this is in the next chapter. Where if you can't do your substitution. So I want you exposed to it to see how, but it doesn't, in the cases of ones like this, you don't have to be able to do so.
Typical list is going off without anybody watching. You know what I'm saying?
Well, I figured y'all would know how to solve for 9 now.
No.
Y'all said you didn't get this way.
We don't know how to. Yeah, I went slower than you.
Okay.
You suck.
So, do y'all get how to go here?
Go.
Do y'all know how to get there?
Yes. All you do is plug in 9. X equals 9.
Alright, so what she did, she found the derivative, she knew f of u was u cubed plus 1. Yes? Are y'all
Yes.
listening? That was given. So when she found the derivative of u cubed is 3u squared. The derivative of 1 is 0, right? But I have to include the du, that's the piece most
chain rule.
missing.
I
So
wanna
then
do the
she
next
came
one.
over to the right and she said, well, to evaluate this, I need to know what is u,
U is 3 of square root.
and what is du. Well, du is the derivative of that. And then all she did from there was she plugged in the u for the u and f
Okay, I can see that now.
Like, get you the answer. I want to see how it gets.
And then it's 3 times 81 times 3.
I got that too.
6.
I did too. Where's that point?
2.
Where's my nugget?
43.
All right, Miss McGee, I want to do the next.
Okay, I also thought it could be 121.5,
Okay, Miss McGee, I
and
didn't
it
say
could
something.
be one. I thought it was gonna be C because of that. I didn't put the
Miss
242.
McGee, the first time I worked this out, I got 3/4, so half this class.
I told you
Okay,
3/4.
let me work it out.
It's
the other
because you
way,
didn't do
so-
this one.
Okay. Let's say on this one, you looked at it and you went, holy crap. I don't remember. No, man.
Okay, so I got my first time doing it, I got the derivative of u and plugged in 9 to it, and then plugged that into what I thought was the derivative of the equation, but I didn't add the du. So.
I'll do number 6.
You got number 6?
I guess correctly, yeah.
So if you did this the plug-in method, then what you're finding is f of 3 times the square root of x, right? Which is, and then you're going to prime, so then it's 3 times the square root of x cubed plus 1.
Now seeing it like that, I see. Wait, where do you get the 3 from? Where do you get the cube from? And a plus 1.
It's 3.
If f of u is u cubed plus 1, and u is 3 times the square root of x, so this would be 27 times the square root of x cubed plus 1. So now f prime of 3 times the square root of x no, it's 3 root x.
We forgot to keep the 2 up there, bro.
What?
No, it's 3 times
3 times 3 is 9, you know what 9 times 2 is?
Because that's a cube.
No, but what I'm saying is when you do the power rule, I thought you just multiply.
No, that's not power rule. She distributed. She distributed the cube.
Oh,
better.
Okay, but then why do you keep that x square root x?
So that's why I got it right.
I feel like it'd be easier to do the power.
What are y'all talking about?
They're confused about this cube.
So this is really 27 times x to the 3 over 2 plus 1. Is that easier?
Well, I did the power rule there because I'm so laughing.
I don't know what you did from right there. I thought you could plug in 9, you could get 3 square root of 9.
I did not do it like
cube
this.
plus 1, and then that's
Like,
Okay, so you just plugged in early. The square root of, wait, no, you can't plug in until you take the derivative. You have to take the derivative first. We haven't taken a derivative yet, right? Yeah, no, we haven't taken a derivative. This is just f of, so now I'm going to do the derivative of f.
Oh, I did that.
Power rule here.
I'm talking about your first. Like if you say I can't plug in right here, then I use the power rule. This is
Okay, so you could, if at this point, but you're taking the derivative. So if I take the derivative here, I can't plug 9 in yet. I can't plug in 9 until I've taken the derivative. Now, I can take the derivative of this the way it sits. I just manipulated it a little bit to make my power rule easier whenever I did take the derivative. If you didn't, if you left it like this, then you could do 3 times 3 root x to the second. That's power rule, but now I have to chain rule it.
yeah, then you did inside.
So the derivative of this, right? Are y'all following me?
Yeah. But what about plus 1?
What about what?
You don't do that plus 1 into it?
Well, what's the derivative of 1?
Oh, 0.
0. So I find this a little more complicated to do. I find it easier if you come down here, because now I've got 27 times 3 over 2 x to the 1/2, and then the derivative of 1 is 0. And now you could put the 9 in there.
Now you can plug in 9 after answer.
Because I know the properties of exponents here.
No, I don't think that goes to the right number.
If I now plug in 9 for this, I get 27 times 3 over 2 times 9 to the 1/2. 9 to the 1/2 is 3. 9 to the 1/2, you don't know?
Oh.
Man. This one,
So then you got 9 over 2, 9 times 27. I guess 242. Okay. Let me do
yeah, but everybody around you didn't. That you distracted them.
All right.
All right. You're doing number 4? All right, I want to get through these quickly because we have a lot to do today. All right, so 2 different ways, same thing.
There's 2 different ways for this.
Implicit, the last
All
three
right.
were implicit differentiation. If you figure that out.
No, I do that.
Actually, number 6 was just chain rule. Number 4. Yeah.
All right. So you gotta do a little bit of product rule up in here. So take the derivative of the first, which is just 1, and then times y plus x dy dx. The derivative of y would be 1, but I just didn't include it. So, and then equals cosine x times 1 plus 2y. Yeah. Okay, yeah. So yeah, but so you did power right there. Well, you didn't have to do the channel right there, but like on that one. But I just wrote it because I was scared Miss McGee wasn't going to give me points. Yeah. So then I did this in one step, but I just made all the dy dx's go on one side, so it ends up looking like this: negative 2y dy dx plus x dy dx. Y'all are still following me, right? Yeah. Okay, good. All right. And then on the other side, you've got cosine x minus y. Y'all aren't confused by any of that, right? All right, good. All right. And then you factor out the dy dx, so you get dy dx times negative 2y plus x equals cosine x minus y. Huh? Alright, bro. Dang. And then you'll divide this, but I'm not gonna write it. So, and then you get a dy dx equals cosine x minus y over x minus 2y.
Oh, yeah, absolutely. But you are excited about it somehow. I don't know why.
Forgot to like write that too.
But I'm not always excited about it. Sometimes I feel like I'm just spinning up. Depends on the feedback of this last 2. My second block, the third block.
Yeah, like I feel like when you have to do the third block, isn't that thing?
We always delete them.
So different.
Don't delete it. I want him to see it.
I have Wednesday night class.
It's just the smiley face, just for you.
Okay. Number 5. What time does our bell ring?
No, whole 45.
Did I not do it good enough?
I thought you did a stellar job.
I did my best.
You did a wonderful job.
What'd you call me, brother?
I was just happy I got that
This
one.
time.
Okay, guys, so
Wait, you told me what?
it's asking us to find the equation of the line that is normal to the graph. Blah, blah, blah. At 2, 3.
Oh.
So first, we have to find the derivative of 4x plus 2x squared y minus y squared. So, 4 plus, now we have to do the product rule for these two. So it turns into 4xy plus 2x squared dy dx.
Why, or do you have to change it?
Find the derivative. 4 plus 4xy plus 2x. Yeah, I got this one.
Minus
2y.
2y dy dx
So,
equals 0. Yes.
when we had the 2x squared times y, why wouldn't we take the derivative of y too? Wouldn't it be 4xy d by dx or not? Wait, what? You know what I'm saying? Well, the derivative of y is 1. Not, so like, you see what I'm saying over here? Like, it's 2x squared times y.
So technically, you're taking, that's like a product rule, because you're taking the derivative of the first, which is 2x squared, which is 4x, multiplying it by y, and then adding the first term times the derivative of y. So now, you have to get the dy dx on one side, so it looks like this 2x squared dy dx minus 2y dy dx equals negative 4xy minus 4. Now factor out the dy dx's.
Why do you have that extra minus 2y d by dx?
That's the other dy dx term. Underline what? So look, right, let me change the color. We had one here, and we had one here. So you have to put them
Alright, go ahead.
here.
Go ahead.
Nah, we just had.
Look, I thought it was just one.
There's two dy dx's, one on one side, one's on the other. So you have to get them on both sides.
Go ahead.
Okay, Ben, are you okay? What's your question?
Go.
Okay, so now we have 2x squared minus 2y equals negative 4xy minus 4. So now divide by 2x squared minus 2y. So then we have dy over dx equals negative 4xy minus 4 over 2x squared minus 2y. Now we just plug in 2 and 3 because I didn't simplify. But you don't have to. I didn't ask. So now you plug in 2 and 3.
You can take a 2 out of everything.
I know. But do we have to? No. So we're not.
No cap, I got no clue what I went on this one.
So you end up getting negative 8 times 3 minus 4 all over 2 times 4 minus 6 equals.
And then you do the opposite reciprocal. Right. Right. So we're solving for the tangent.
So this is a slope for the tan line.
Nah, my equation I got at the end was wrong.
Okay, this is the class order. This is the slope of the tan line. We're finding the slope of the normal line. So you have to do the reciprocal of negative 14, which turns out being 1 over 14. Are we with me? So the equation would be y equals y minus 3 equals 1 over 14 times x minus 2, which turns into y equals 3 plus 1 over
Yeah, well, once I
14
do the derivative and I'll
x
simplify
minus
it,
2,
it's just
which is also known as b. If they don't want to learn it, they're going to fail the thing again. Not my problem. I'm sorry, I couldn't be a teacher. I would kill my students.
Shut up, Leah.
I explained it in a good way. They weren't paying attention.
Oh, yeah, scroll back down. What did you do right here?
Yeah, I'm doing 6.
Okay, so I plugged in 2 and 3 to my equation. Yeah, so I plugged in 2 and 3 for all this, and you get negative 28 over 2, which is negative 14, right? You need to find the reciprocal of this for the normal
I
amount.
understand that. What is all this red rectangle with 3 and 4?
That's me plugging in the 2. Oh, I'm sorry. That's simplified. Like negative 8 times 3 minus 4. And then
Alright.
I'm doing number 6.
Well,
All right, last one. Let's get through this quickly so we can. Did y'all have any other questions about that one?
No, I guess
You got it right.
All right, number 6. All right, guys. Y'all sure you want to do this?
This is number 6.
I don't know if this is gonna work out
Trying to
well.
do y dx. So the first thing you're gonna do is move this to the top. Oh, yeah, just go ahead and write the top. This one. Yeah. Right. Alright, go ahead and write dy dx somewhere. So move that to the top. So the radical to the top. But first, we got to make this a exponent. So the square root will be to 1/2 of this. So like 1 over to the 1/2. And then that's not a 3. That's a 2. How do I get rid of that shit? And then, so then we're gonna move this to the top. So all you have to do is make that negative. Put it at the top. So 1 to the negative 1.
It looks like you're on a thing.
No. Get rid of that. Get rid of all that. How do I get rid of all that? How do I delete it? Oh,
All right, come on, guys.
we're gonna have to. How do you erase something? Here, look.
The back of the pen.
Oh.
Just let one person do it.
Yeah.
Well, I'm trying to. He wants to do it, but I'm helping him.
That's not like,
All right, so we're doing this, right? What? Just put it back.
I got
Just
the
do
whole
it.
equation.
Oh, here's the
I
eraser.
think it's somewhere in my.
Erase it quick.
No,
Oh my God. All right, that's what. Oh, shit.
no, I got
Where's the
it
pen?
wrong. I got the wrong equation.
So this equals.
It wouldn't have been.
So look, we're gonna move this to the top. Hello, order in the classroom. Squared plus 1 to the negative 1/2. Right? Are we all there? So then we're gonna
He
power.
just changed this to. Instead of a fraction.
How'd you move it
So
to
he
the
made
top?
the square root of negative 1/2. All right, now power rule and chain rule. Come on.
Right, so equals negative 1/2.
But I thought it was still under
squared.
1.
Huh?
Isn't that still under 1?
Well, yeah, it is under 1, but it doesn't. No. It's to the top. It's over 1.
That's gonna be negative
Just move that to the numerator.
Change the exponent of negative 3 over 2.
No, we already did that.
I didn't know you could just move it to the top like that.
They're negative.
Right.
The negative equals right, yeah.
And now we're going to simplify this. So 2x times negative 1/2 negative x times. I'm writing huge.
Feels like
I don't have a clue what I did.
So I got to keep.
Anytime you move anything, if you move it to the top.
And now we're going to move it back to the bottom to get rid of the negative. And then it's 3 over 2. Thank you. And then
Properties of rational
we don't want to,
exponents.
right, so we got to put this, since all the answers are in radicals, we got to put this back into a radical.
Wait, can you do a double click? Where did you get negative x from?
Oh, 2x times, oh, you want me? The 2x times the negative 1/2, you're just multiplying the, and then the 2's cancel, so it's just negative x. Anyway. Right, so we got negative x over. We're going to put this into a radical, so it'll be the square root because the denominator is a 2. So we don't even have, you don't even have to write the 2. X squared plus 1 cubed.
The bottom is the
So yeah, it's like this goes here.
Yes.
But I mean, a square root, it's just a square root. So
I understand that, but then so the numerator is the exponent.
the numerator is the exponent, yeah. Okay, if this was, to make it, if this was, if instead it was x squared plus 1 to the 2/3, it would look like the square root, or the cubed root. It would look like that. So then the answer is B.
You put it to the top and just flip that.
You just make it, you flip the sign of the exponent.
McGee, I want to say this again. I made some stupid mistakes.
Keep this with your FRTs that are doing stuff like that, because these are, I try my best to pull from old exams and stuff when I do them. All right, let's move on. How about questions about your homework? With Verge. Don't you love her? I really like her. Yeah. She does a lot of, Verge and Mark do a lot of the things I follow on Facebook too. They're really good. 36. Let me also give you just a little bit of, not really notes, but a little bit of a helpful hint as you do these kind. So here is the basic idea here. When you're finding a point of tangency that is the inverse function, okay? So the first thing I want, so for instance, this says f of x equals, which one did you say? 36, okay. X to the 5th plus 2x cubed plus x minus 1. And part A has you go through and find f of 1, and you find that to be 3, and have you find f prime of 1. And I'm going to assume nobody had trouble doing part A on this, right? Y'all okay there? Okay, 36. So here's the general. I'm sure she's fixing to announce.
Are you sure that, like, isn't one that
Should I walk out there just to see what other people do?
Oh, yeah, I thought,
Hey,
yeah.
Miss McGee, can I walk out just to see if other people?
I'm sure they're not. All right, so here's what we're going to do, because what we're asked to do in part B is find the inverse at 1 and then find the inverse. I'm losing my place here. The inverse of the derivative, like this. The derivative of the inverse. It's very confusing. It gets confusing. But these points, this 1, 3, and this 1, 12, these are going to be your keys for helping you find the derivative at a point of the inverse. So here's the easiest way that I know to tell you to do this. The first thing you want to do is you want to derive, just the way you do normally. Okay, so find f prime of x. 5x to the 4th plus what? Plus 1. Everybody okay there?
That other stuff is given, correct?
Okay, so yes. 9 times out of 10, these things are given.
They're not hard to get though.
Okay, they're not hard to get. They're not hard to get. All right, so here's what I want to do. I want to if this is my point in my real world original equation, right? What I'm really wanting to find when I'm looking, and I'm going to look at this one first, the derivative here, the derivative of 3. By that definition that I gave you, what I'm really going to find is the inverse. I'm confusing. I'm going to confuse y'all like this.
Wait, Miss McGee, what are you trying to do right now?
Did you understand the chart thing? Okay, well then let's do the chart game. Forget this. Well, but she did f of x, right? And so she did x and y. So this was 1 and 3. Yeah, don't do that. I was going to give you steps. I was trying to make it to where it could always, yeah. Well, 1 and 12 that's my derivative, right? Right? So then f prime of x. Is this the way she did it? I can't remember.
Basically to the center of the top.
What? Because the slope of these two is 12, is what you're saying. Yes. So the inverse derivative at 3 would be the slope, the reciprocal of this slope. Yes. 1 over 12.
A negative 1 over 12.
Wait, so you just swap the x's and y's?
It's not negative reciprocal, it's just reciprocal. So the formula I gave you yesterday said if you have, Lord, let me make sure I give it to you right now. The inverse of, if the inverse of B, the inverse at B is A, then
Yeah.
the derivative, the inverse, the derivative of the inverse at this point is the same thing as the flip of, this is actually the y coordinate of, this is a point, this point is BA, right?
Oh yeah.
So you're plugging into the derivative, you're plugging the y instead of the x.
You said the inverse times that point times that point. It's the same as 1 over the first one. What is the second? What is that equation on the right? Right there.
Where?
On the right.
Here?
Yeah.
That's this in words.
What do you mean by flip?
Okay.
Put it up under.
It was 12, so make it 1 over 12.
That's pretty simple right there.
Okay. So essentially, so look at this one. So we had 1, 3, right? The derivative, f prime of x, we said was, I wrote it somewhere, 5x to the 4th plus 6x squared plus 1, right? So because here was 3, yes?
Yeah.
Then I plug that, if I plug in the other in and then flip it, is essentially what I'm doing. I know, I'm. Say that again?
When I was doing it, I just wanted to change my answer. Like, I was doing I was like,
Yes. So, no, you're doing the same thing. You're just, yeah. If I'm finding the inverse, the derivative of the inverse at 3, then I look at the y. I go back to the original equation, right? I know that the slope here is 12 because f prime of 1 we already found to be 12. So that means that the inverse derivative at 3, because I'm switching x and y, is 1 over 12.
What you're telling me is plug an inverse derivative in.
All right.
is it negative 1 over 12?
Here, this, I have to find out. The reason you were given this is because you found these points. You want? Let's do a fresh problem. Let's do a fresh problem. This point is on the graph. I want you to find the inverse, the derivative of the inverse at 10. So what this means is, remember, inverses switch x and y, right? What this means is, I look at this point, 110. I'm going to switch, instead of it being 10 in parentheses, it's going to be 1 in parentheses. So I'm going to do 1 over the derivative at 1. Find the derivative at the x instead of the y and flip it over. So this would be, so I've got, the derivative would be 3x squared plus 7, right? If I plug in 1 there, f prime of 1 would be 10. But you're going to flip it. Slope equals 10 at 110. So at this point, the slope is 10. So if you want the slope of the inverse, you would flip it. Just flip it. Just flip it. Correct. So instead of, since this was telling me to look at 10, then I do the derivative at 1 and flip it. Okay, do another one. Oh, I think it's the same one y'all just did. I didn't know. I'm going to tell you that 0, 1 is a point on this graph so that you don't have to actually go through and find it. Now I want you to find the inverse derivative of 1. Nobody say the answer. You what? Plus 8. I don't know how to put it in words very well. I'm sorry. Clearly, I confused you trying to put. Because since it's an inverse, which switches x and y, because I was asked at 1 here, and I have this 0.01, then I plug in the x part instead because I flip it.
Change signs to y.
Inverse means switch x and y, yes? So instead of plugging in 1, I'm going to plug in the other one when I do the derivative.
Yeah, I got it.
Yeah.
Yeah, I got it. You get one more.
One more?
Because it never happened to me. I was like, I'm an idiot.
I don't know if,
Okay, real fast.
yeah.
Whenever you have that times 3 on there, and okay, you know that 3 is plugged on to the sign of 0? So you know how to cancel it out? Like on my I'm looking at two derivatives. Like I think you moved these two things to the front,
I did because, yeah.
and when you plug in, so like, how do you like? Are you just supposed to know that when multiplying those things go together, you can cancel it all out?
Well, because the sign of 0 is 0, and 0 times 3 is 0. I don't know, I haven't worked it yet. Right. Correct. If f of x is 0, 1, then the inverse of x is 1, 0. What do you mean you don't want? Okay.
So I'm just going to plug in my name as the name of 1. I'm just going to plug in as a 0 in my place.
I think you're doing the steps, but you're doing them backwards. I feel like you're flipping first and then you're plugging in. Is that what you're saying? Yeah.
I don't know like what I'm doing. Like I know as the name of
1 over f prime of x. So 1 over the derivative of f of x. Let me find you some better. Yeah. Let me get you some more on this. And I'll try to help you some more. I'm trying to think of what I was going to tell you was you find the derivative first. That's what we did here, right? Swap your x and your y. So instead of 0, 1, you have 1, 0. And then plug in to your derivative function, which is here. That's what we did. And then you just flip it over. I was trying to put that in words for you, but I didn't quite get there. Okay. This is literally what I have on my notes to give you. 1 is derived. Swap x and y in your point. So instead of 0, 1, I'm looking at 1, 0. Bless you.
Happy birthday, man.
plug that into number 1.
We're putting in number 1 or putting.
Yes. All right, let me show you. Before I give you your homework, let me show you really quick. These are straightforward because these are just the rules, okay? So your derivative sheet, huh? Yes. I have to write that.
Swap,
Mm-hmm.
plug in F, Y,
Yep.
X.
And then
whatever
flip it
it
over.
is, and then
Mhm.
equals.
Yep. All right, so just quickly, the derivative, this is probably the easiest one, of e to the x.
It is the same.
It is the same, it is e to the x, but don't forget that chain rule. I really need to go back and put these dx's on your sheet. No, it's okay, go ahead.
So why did we never have to do this before? We do it now.
Do you?
Makes me giddy. Why do we have to do the DX like now? We didn't used to have to. Like if we would've
You've
learned-
always done it, the dx has always been 1.
If we would have learned
Just like you
chain
did.
rule from the beginning,
You think that would have been helpful?
I would recommend it for next year. Because it's their fault if they put it after. I don't know why they do it.
Well, it's such a complicated.
Yeah, but if you
learn
understand
it when you
with
learn
the
derivatives.
basic stuff, then you'll understand the advanced stuff. When you say like we've always done it, I don't get it because I haven't.
This is probably the most convoluted one. It's a little bit harder to remember, but this is the difference in an exponential and an e to the x. All right, guys. We got 5 minutes. I'm just trying to run through this quickly so you can get to work on some of it. Again, if you need to chain rule, chain rule.
Is there a reason?
Natural log.
Is there a reason that
So,
e to the x, the derivative?
Wait, is this a new?
yep, this is new lesson. This is new lesson.
Is there a reason that it's the same? Like why is it?
Because the derivative
So a
is
to the x natural log of a.
So
And
why
times
isn't it uy dx?
You don't have what? You're just doing with the straight x here. You just have an x, right? Mhm.
And so why do you mean that? So you can put like finding y. You can like
If this was a to the 2x, or let's say, I'm sorry, 5 to the 2x, the derivative here of this would be
Derivative of a. I mean,
5 to the 2x, natural log of your a, and now you have to chain rule it times 2.
oh, you forgot the dx. You forgot the dx.
The dx is 2. The dx is the derivative
Oh,
of
so
the
that's
x.
what I was saying. I
Yeah.
was saying it, yeah.
Okay. So that's why I'm putting that dx there in case you have to chain rule it. I just want to make sure you understand that the chain rule still applies. No, so go back to your original. The inside function that you're chaining here is this. So this is just when your base is a number,
What is
okay, a
natural log?
constant number.
I really never understood.
It's log base e, which again, if you go back, if I use this same, this is a cool little thing. I probably don't have time to do it, but I'm gonna do it anyway. If I come here and I want to say why is it e to the x, why does it stay the same? I can apply this same property here and say, well, the derivative of e to the x is e to the x natural log of e, but what's the natural log of e? 1. Natural log of e is the same thing as log base e of e. When those are the same, it just equals 1. So that's why it's just e to the x. Okay.
properties? Yes.
It's kind of like the exponential property.
There's two more real quick.
Wait, what's that homework?
I haven't given it to you yet. The derivative of the natural log of x is 1 over x dx. Right here. That I was just showing you why that first property I gave you held true. These are actually the last 4 on your derivative sheet. I know that we are running through this very fast. Of course you need your dx on here. You're going to encounter some tonight where you do need some of those log properties and stuff. If you get to the point where you just don't know, text me or call me or email me.
No, you
Or,
said don't
yeah.
I've considered it multiple times, and I'm just like,
I mean, you can call. I probably won't answer if you call, but I'll probably respond if you text. But I'm not a talker on the phone very much. I do occasionally, but not a whole lot. All right, so I would definitely not answer that.
why would you not?
We are going to do page 193. These, this looks like a lot, but these don't involve a lot of extra properties. I know.
Wow. And more?
This should literally not take you longer than 30 minutes. If it does, seriously, because it's the number 1 is find dy dx.
Okay, alright.
What's dy dx?
A is the dx. Well, you gotta do dx, so then it would be 1 plus or times 1. It'd be the same though. That's it.
Your coefficient stays, right?
Yeah, but you have to do the dx of x is 1, so. Wait.
But that's the last 4 of them. That's all the derivative rules. Yeah.
If it was 2,